Oh, is that not the right packet?
Yeah.
This one? Oh, okay, yeah, it's this one. And, yes. Yeah, you missed a lot, but we're on this question right here. And you might be a little confused today, but just do your best and we'll try to get you caught up, okay? Okay, so question, okay, what is our initial ordered pair? Okay, very good, because look what it says right here. The internal temperature at 0 is 91. So your point... Oh, it even gives it to you. Okay, so they were trying to be helpful. But you should have been able to know from just that sentence that at the beginning the temperature was 91. Okay, then it says it's never greater than 27. Okay, the internal temperature of the potato at time t minutes can be modeled by, then you have an equation. Okay, what two things do we need to write an equation of a tangent line?
A point and a slope.
Point and a slope. We have the point. How do we find the slope? Okay, slope is going to be dh dt, line 0, 91, yeah?
Yeah.
Okay, and we're plugging in 91 right here. So it'd be negative a fourth, 91 minus 27. Now, can you leave it like that? You could, sure. Okay, but what is 91 minus 27?
43. No, that's wrong.
64?
64, yeah.
Yeah?
I was looking at the wrong one.
Yeah, 64 is right. And then divide that by negative a fourth? Negative 16. Good. Okay, so from there we have our point, we have our slope. We're writing the equation of our tangent line. So it would be y minus 91, negative 16, x minus 0. Now, what are we using the equation for? Approximate the temperature at 3. So what am I going to do with 3? Plug it in for x. Normally they'll give you like a funny decimal. In this case, they just give you a different number. Okay, so what is 3 minus 0? 3. So y minus 91 equals negative 16 times 3. That's going to be a negative 48. And then what would I do with the 91? So negative 48 plus 91. You can leave it like that. That's good enough. Okay? Part B says, use the second derivative to determine whether your answer in Part A is an over or an underestimation. Remember that when you want to know if it's over or under, you are checking the concavity. So we need to take the second derivative. Remember that it's easiest to do that if you distribute your negative a fourth into your dh dt. So it'd be negative a fourth h and then plus a fourth times 27. Okay? So I'd take my negative on my fourth and I'd multiply that in. Now, when I take the second derivative, what is going to happen to that constant? It's going to go away. What's the derivative of negative a fourth h? Negative a fourth times what? dh dt. Because remember, dh dt, h is not the letter on the bottom. If it were t, you wouldn't have to do that. Okay, and then from here, I want to know concavity. What was dh dt in the previous question? We just did it in Part A. Negative 16. So if I plug in negative 16 times negative a fourth, how is that going to come out? 4. It's going to come out to be positive. So dh dt squared at 0.91 is going to be negative a fourth of negative 16, which is greater than 0. And you don't even necessarily care that it's a 4. You just care about the sign. If they're both negative and you're times them together, that's going to be positive. What does that tell us about concavity?
It's concave up.
It's concave up, and if it's concave up, where's your tangent line? Is it an underestimate or an overestimate? Under. Okay, so, therefore, H is concave up, and the tangent line is under the actual value. Everybody remember that? Yeah? Okay. Now, part C is going to get a little bit tricky, okay, but this is the first one with the 2/3 we've done, but we've done integrals and derivatives with that before. But it is uncommon for you to see these on the AP test, but they could put it on there. They just don't put a lot of them on there. Okay, so look what it says. An alternate model for the temperature is given by dg dt, where G is measured in degrees Celsius and G of 0 is 91. Find an expression for G. What did they give you? dg dt. What do they want? G. So how do I get that? Do the antiderivative. So if I have dg dt, then I need to do the antiderivative so that it's just normal G. Does that make sense?
Yeah.
Okay, so look at your equation. Yeah, we need to integrate, but in order to integrate, we need to separate first. And so that's what we've been practicing this week. So this entire thing right here is going to have to divide over to this side. And where is my dt going to end up? Over there. So look what I have so far. I'm going to have 1 over G minus 27 to the 2/3 dg. And then on the other side, I just have a -1 dt. So far, are we good with that?
Yeah.
So we took the G crap, divided it to the bottom. We left the -1 as our number that's going to stay on that left side. Now we're going to integrate. On the left side, we are going to need to do U substitution because your G minus 27 is in the radical. So if my U is G minus 27, what is du? What's the derivative of G? Or what's the derivative of X? 1 dg. And if du and dg are the same, then I'm ready to do my substitute. Now question, if my integral is this, 1 over u to the 2/3, is that going to have an ln in the answer, or do I need to rewrite that as a negative power? You have to rewrite it as a negative power. So it'll be -2/3. Okay? And so now do power rule on that, and I want you to think about the fraction-y part of it. So if it's -2/3, and I add 1 to that, what is -2/3 if I add 1? 1/3. And then if I have to divide by a third, I'm really multiplying by what? You have to flip it. 3. Now, the other side, the integration is going to be pretty easy. What's the integral of -1? -1t plus c. Now, we have to go one more step. If your u is still in your equation, you have to go back to the G minus 27. So it's 3 G minus 27. And then if it's a 1/3 power, is it okay if I write that as a cubic root? Okay, because we know that that's the same. And then -t plus c. Okay, what would I do next? Remember, we need to get G by itself eventually. What would I do with this 3? So to get rid of a 3, yep, I'm going to need to divide. So I'm going to divide by 3. 3. Do I need to divide the c by 3?
No.
Okay, technically you are, but you don't really care. So these guys are going to cross out. Now you have the cubic root of G minus 27 is -t over 3 plus c. What would you do next to get rid of the cubic root?
Cube it?
Cube. And when I cube, am I allowed to only cube this one?
No.
You need to group and then cube. Okay?
And then add 20.
And then add the 27 across. So your cubic root and your cube cross out, and you have G equals -t over 3 plus c, quantity cubed plus 27. Okay? Whoa, that's great. And then what additional, are we done? Or do we have like one more thing? We're not quite done. It's okay. What do we need to still do?
We have to
You need to find C. How are you going to find C? Right here. G of 0 equals 91. So 91 is the temperature of the potato at time 0. Right? So we need to go back and find that C. Now your 0 is just going to cross out. Okay, so it's C cubed plus 27 is 91. What would I do next?
27.
Yep.
And you have 64.
Yep.
Dang.
And then that's really just a C cubed because the 0 crossed out.
So take the cube root of 64.
Yep. Not 8.
4.
4. Now, if you didn't know what the cube root was, you leave it as a cube root of 64 and you don't make it pretty. You don't have to make it pretty, so don't do it, okay? So my final answer, I would come back to right here, but I'm going to replace my C with a 4. So G equals negative T over 3 plus 4, quantity cubed plus 27. Okay, go back and reread the question and see if there's anything else that we still need to do after we find an expression for G. What does it say next?
Find the temperature.
Yeah, based on this model, what's the temperature at 3? So what do I need to do at 3? Plug it in. Very good. So now this is for any time. Now we need to find the temperature at 3. So that would be negative 3 over 3. What's that then? Negative 1 plus 4 cubed plus 27. Is that good enough for your response?
Yes.
Yes. Okay, but if it was multiple choice, what's 4 minus 1 in the middle? 3. What's 3 cubed? Squared would be 9, then one more would be 27. Plus another 27 is 54. So if it was free response, that would have been fine. Okay, but if it was multiple choice, you should be able to do that algebra. Make sense? Okay. So we are finished with that. We're going to actually take kind of a step to the side and work on slope fields for a little bit. Do y'all remember when we did slope fields in the fall?
I don't even remember what I had for dinner.
No,
last
it's
night.
like a picture with a bunch of little lines on it.
Oh,
A little bit.
Oh,
Remember
right.
you talked about it's kind of like a magnetic field
ish.
ish. Okay.
Magnus.
Can you go on? So this is going to be pretty easy compared to what we've been doing, at least at the beginning. Okay. So we're going to skip number 1 for right now, just because we've already done several. Actually, do y'all want to do that one? Just to kind of
Yeah, refresh.
refresh? Okay. So what would you do first on number 1 there? And on this is what you missed. You want a pen?
Yeah, I think I have one in my
Okay, so what would I do to separate that first one? Okay, but if y was on the bottom, where is it now? Okay, so y dy, x squared dx. Then I'm going to integrate on both sides. Oh yeah, I had given, sorry. Okay, what's the integral of y? 1/2 y squared, yeah? And then what's the integral of x squared?
1/3 x cubed
Plus c.
plus
Okay, remember we got to get y by itself. What do I do with the 1/3 or the 1/2?
multiply by 2.
Multiply by 2. So my 1/2 is going to cross out. I have y squared. This is now a 2/3 x cubed. Do I have to change that to a 2c? No. Then from there, y equals plus or minus, and then square root of that expression. 2/3 x cubed plus c. Now remember, that is your general solution. To get the particular solution, you would have to plug in your point. What point are we plugging in?
Y3 -2.
Good. -2 is the answer when I plug in a 3 on the inside. So 2/3 3 cubed plus c. Now remember, you do have to choose between the plus or the minus. So if I want -2 to be my answer, which one am I going to pick?
Minus.
the minus. And then from there, when I square both sides to kind of break the c out in a second, that negative is going to go away. But we're picking the minus right now. Okay, in here, what is 3 cubed? 27. Now let's divide it by 3. 9. Then we're going to times it by 2. 18. So I have negative 2 equals negative square root 18 plus c. Then from here, I'm going to cross out my negatives. Okay, because there's 1 on both sides, and then I'm going to square. When you square the square root, they cross out. 2 squared is 4 equals 18 plus c.
Subtract 18.
Yep.
12.
Close?
14.
14. Okay, look at your answer choices. Which of those is going to be right? Which one? E. Yes. Why can't it be D? Because that has the negative 14. Yes, you have to have that negative on the outside. So E would be correct there. Huh?
We had to skip it right there.
Oh, yeah, you're right. I guess when you pick the negative, you know.
That's right.
Okay. Alright, so let's talk about slope fields. When dealing with differential equations, you can read this little paragraph, but I'll read it to you. Often it is not possible to find a solution by analytic methods, but we can... What is that supposed to be? Oh, we can use slope fields. We can use slope fields to observe characteristics of the original function. Okay, to create a slope field, this is really not hard, it just might be annoying. Okay, you're going to evaluate dy dx for each ordered pair, and then you're going to sketch a little line segment with that on that ordered pair with that approximate slope. Slope fields outline the shape of the solution, or the particular solution. I wrote it backwards. Okay? Okay, so let's look at the first one. If your x was 0, what would your slope be here? If x is 0, what would your slope be? Plug in 0. Easy question, not a trick question. 0 plus 1 is 1. So on your x equals 0 column, I want you to put a slope of 1. Now we're going to move over 1 to the right. So if this is the x equals 0 column, this would be all the points where x is what? Right here, this one. 1. What's 1 plus 1? 2. How should that slope compare? Should it be the same, steeper, or flatter? Steeper. So make your 2 slope a little bit steeper. Okay, next one. We're moving over 1 more. This was x equals 1. Now we're on x equals 2. What is 2 plus 1?
3.
So a little bit steeper. And then what would happen if we went over even 1 more? Steeper again. And you can just draw in a steeper value. Okay, now we're going to work the other way from 0. So to the left of 0, what would my column be?
Negative 1.
What's negative 1 plus 1?
0.
What does that slope look like?
It's flat.
Flat. So 0 slopes. And then when I go to the left even 1 more, I'd be at x equals negative 2, yeah?
Yeah.
What's negative 2 plus 1?
Negative 1, so it's a negative slope.
Negative slope. And then what's going to happen if I move over 1 more?
It's a negative slope,
But
but it's steeper.
it's steeper. So usually with these, you can pretty quickly identify the pattern. Okay? But what I want you to notice right here is that differential equations that have only an x are going to have slope fields with columns. Okay? Now, you're going to notice that the opposite is true with the second one. If I go to the second slope field here, look at your formula. What is the only letter in it?
Y.
A y. And so if I'm picking out points with a common y value, you're going to see that you're going to have rows. So for example, if I do this row right here, this is y equals 0. Every point on this line has a y value of 0. What's 0 minus 2? Negative 2. So I'm going to make all my lines go downhill. And then I'm going to go up, but you could go down first if you want to. Okay, if this is y equals 0, this is y is 1. What is the slope of this equation when I plug in a 1? Negative 1. Should it be flatter or steeper, though? A little bit flatter. Still downhill, but not as steep as the previous one. When I go one more step up to when y is 2, what are you going to find your slope to be? Zeros, which means it's flat. And then if I go up one more, that would be y is 3. When y is 3, what does that slope formula come out to be? 1. So those would be uphill. Now, rather than continuing to plug in each of these numbers, think about the pattern. As my y gets more negative, what's going to happen to my slope? It's going to just keep getting steeper downhill. So you can just sketch that in. So it would be steep, steeper, and then really steep on those last ones. Okay, but it doesn't have to be perfect. That's not the point of doing it. The point is that you would understand how they work. You are plugging in the points to the formula and then sketching a slope with that approximate steepness. Okay, so if your differential equation has only y's in it, your slope field will have rows. So if it's an x only, it will have columns. If it's a y only, it will have rows. Does that make sense? Okay, turn the page. Okay, next one. What value of x is going to zero that out? Look at your equation.
1.
When x is 1. So go to x equals 1 as your column, and I want you to draw in all flat spots. When I go 1 to the right, that would mean that x is 2. What is your slope? So it'd be 1 minus 2, which is negative 1. If I go over one more, what is my slope going to be? It'd be steeper, but still downhill. Okay, now we are not going to do all of the columns on this one, but we're just going to do 2 more on the other side. If I plug in 0, what would I get? 1. What about if I do negative 1? 1 minus negative 1, what would I get? 1 minus negative is plus, so that'd be a 2. And so what's going to happen as I go out this way? It's going to keep getting steeper, okay? Now, what we're going to do now with this same thing is we're going to also solve it, okay? So I have dy dx equals 1 minus x. I need to separate first. If there was y stuff, you would have to move it over. But if there's not y stuff, you are only moving the dx. So pull your dx right here, and then we're going to get to solve this right off the bat. So dy equals 1 minus x dx. Now, if that left side is just a 1, I'm going to put 1 in front of that. So what is the integral of 1 with respect to y? Y. On the right, what's the integral of 1? X. What's the integral of minus x? Minus 1/2 x squared plus c. Then they're giving you a point right here, 2, 0. That means that 0 is the answer when we plug in 2. 2 minus 1/2 2 squared plus c. What is 2 squared? 4. What's half of 4? 2. So that'd be 2 minus 2 plus c. What is c? 0. So then you would cross that out, plug in a 0. That would be your solution. Now, can you tell me just real quick, what is the shape of this graph? You should be able to tell based on the negative x squared. What shape is that? Quadratic. How does it open? Down. If you look at your picture, can you kind of tell 2, 0 would be right here? And if I connect the magnetic field, if you will, can you kind of see how it makes that shape? Okay, so your slope field should match the shape of the solution. Does that make sense? Okay, and that is going to be true for all of the remaining examples that we're going to work. Okay, so next one. Where would your flat spots be that would make y plus 1, 0? Okay, what would have to be negative 1 though? X or y? Y. So this is going to be a 0 slope when y is negative 1. Is that a row or a column? That would be a row. So y is negative 1 is here, and I would draw in all my flats. Okay, let's plug in y equals 0. What's 0 plus 1 all the way across? So 1, 1, 1, 1, 1, 1, 1. What about if I go up one more?
2, 2, 2, 2.
Yep. And then if I keep going up again, it'd be 3, 3, 3. So what's happening as my y's get bigger? It's getting steeper, yeah? Okay, now we're going to solve it and see what solution that slope field is actually representing. Remember, the only way to do that is by separating. Now, did I have only an x or only a y for this one? Only a y. So when I take my y plus 1, you are not allowed to subtract that y across. You need to think about that as times a 1, and then divide that y plus 1 to the bottom. So my dx is going to move up here, and my y plus 1 is going to have to divide to be on the bottom on the other side. So it'll be 1 over y plus 1 dy, and then 1 dx. Does that make sense how we separated that? Okay, integrate both sides. On the left, you're going to need u substitution. What would your u be? And what's the derivative of y plus 1? 1. So you can go ahead and rewrite 1 over u. Integral is ln u, which is y plus 1. Okay, so again, the reason you're allowed to kind of fudge the u substitution is because if this is a y plus 1, the derivative's 1. So nothing weird is going to happen. You could show all the steps if you want to, but you don't have to. Okay, on the other side, what's the integral of 1? X plus c. And then how would I get rid of the ln? E both sides. When I e the ln, they cross out. I have y plus 1 equals. And then where is this c allowed to move? Down to the front. So it would be c e to the x. And then if I take that plus 1 across to the other side, it would be c e to the x minus 1. Now, can you just think about the shape of that? If this is an e to the x equation, what does that look like? E to the x. What's the shape of that? Exponential. Look at your graph. Do you see how it's like exponential? And what would the minus 1 do to the graph? It would shift it down. So instead of it having an asymptote at 0, it's asymptoting at minus 1 instead. Does that make sense? Okay, so sketch the shape in there. Your graph would look like this. Okay, and that should match the shape of an exponential graph that is shifted down 1 unit. Okay? Alright, we're going to skip the next one and go to some of the combos. Okay, but actually on number 5, question just real quick. Would any of your little lines be downhill? Would any lines be downhill on the graph of number 5? No, because no matter what x, when you square it, it's going to always be positive. Okay, and so it's important to notice details like that, because if it's multiple choice, they'll give you like 5 slope fields Stuff like that can make it really easy to throw out answer choices. Also, one more question. What would x not allowed to be for this? What are you not allowed to divide by? 0. So this entire column would have to be left blank. Okay, because x equals 0 cannot be on the bottom, because you're not allowed to divide by 0. Okay, so when we look at some of these that are multiple choice, noticing stuff like that will help. Letters on the bottom cannot equal 0, or else you'd have an undefined slope. Okay? So turn the page, and let's do number 8. Okay, now, first thing I want you to notice is you see you have x's and y's. That means it's not a row or a column, it's going to be a combination. Okay, so what x's will make that slope flat? Okay, this is going to be a 0 slope when x is 2, or what else? When y is 0. So I want you to draw in flat spots everywhere that x is 2 or that y is 0. So 2 would be here, and y0 would be here. And then from there, this is where it gets a little bit annoying. You would have to plug in the points to know the slope at those values. So to make this easier, we are only going to do these points. But on the AP test, they would never make you do one this big. Okay, so let's go one at a time. So this point right here is 0, 1. So plug in 0, 1 to your equation. I'd have a 0 here. What's that? Negative 2 times 6 times 1. 6 times negative 2 is negative 12. Make it steep downhill. Yeah, just pretend. Okay, this is 0, 2. This is still a negative 2, but now I'm timesing this by 2 instead of only 1. So now it's negative 2 times 12. So steeper. And then if I go up 1 more, what's going to happen again? Even steeper. Okay, so you don't have to find the exact slopes, you just have to recognize the pattern. Okay, now we're moving over 1. This is 1, 1. So on the outside I would have a 6. 1 minus 2 is negative 1. What's 6 times negative 1? Negative 6. And then if I go up 1 more, my y now is a 2. So I'm at 1, 2 here, right? So that'd be 1 minus 2 is negative 1. That's a 12. So that'd be a negative 12. If this was a negative 6, how should that compare? Steeper. And then you notice the pattern. What's going to happen if I go up 1 more? Steeper. Okay, then let's go out to this row right here. This is 1, 2, 3, 1. And I'm plugging into this formula right here. So my 3 minus 2, what's that? 1. And then I'm plugging in a 1 here. So that's 1 times 6 is 6. Which way should your line be going? Uphill. But then as your y's get bigger, what's going to happen to your slope? Still steeper, but it's going to be steeper uphill. Okay? Alright, so now we're going to solve this one. Okay? So dy dx equals 6yx minus 2. What has to move? So the dx has to move to be by the x minus 2. Do I have to bring the 6 with the y? No, and I wouldn't because you don't want fractions. So I'm going to only take the y to the other side. So it's going to be 1 over y dy. And then on this side, if I have a 6 and an x minus 2 both staying, is it okay for me to distribute that? So that would be a 6x. And then a 6 times 2 would be minus 12 dx. And then from there, we're going to integrate on both sides. Will I need any funny rules? Okay, I'll use ln, but I won't need u sub. I won't need to rewrite. Nothing like that. What about this 6x minus 12? What's your antiderivative there? 3x squared minus 12x plus c. Then I would e both sides. When you e the ln, they cross out. Y equals ce to the 3x squared minus 12x. And that would be your general solution. Okay? And then if you put this into your graph, it would look this funny shape. We didn't do all of it because it was too annoying, but you could. Okay? Alright, now rewind back to me to number 7. Could you separate that? Are you allowed to minus the y over to the other side? No. So this is not separable. If your x and your y stuff is added and there's no way for you to switch that to multiplication somehow, then you can't separate. Okay? The one right above it we're not going to do, but I want you to just do the separate step on it. How would you separate that top one, number 6? What would have to move? The dx and the y. So separate it for me. Where would the y end up?
The bottom.
1 over y. Good job. And then on the other side, would it be x squared dx?
Dx.
1 over x squared dx. Good. So remember that when you move stuff, if it was on the bottom, if it's staying on that same side, you got to leave it there. How would I integrate the left side of this? ln. On the right side, what would you need to do? That is not an ln. What would that be? A rewrite. How would you rewrite that if x squared is on the bottom? X to the negative 2. And then from there, you would do your integrals, have your plus c, blah, blah, blah. Make sense? Okay. So we're going to save the rest of the notes because I'm not going to be here for 5th period and I don't want to make y'all's notes too long. So